Thank you for joining us at the Generation Green 2021 Youth Conference. This session is brought to you by Marsha Smith. She has worked overseas with NGOs and governments on improving water quality in the Caribbean, and who is also on the board of directors of HEN. Marsha will be presenting a session on Climate 101. Enjoy.
Hello and welcome to Climate Change 101. My name is Marsha Smith. I grew up in Halton and Peel. I have a master's of environmental science from the University of Toronto and a bachelor in geography from the University of Waterloo, where I specialized in biophysical systems and information technologies. So that's the use of satellite data to study changes in natural systems. So satellite and remote sensing data and using computer analysis. Fun fact, I also got my scuba license while I was in high school, and I've taken many opportunities to travel since then, mostly to warmer climates. A few years back, my family moved to a small island in the South Caribbean, where I was responsible for the island's water quality. We got very involved with the local community and with the local cleanup efforts. And in this image here on the bottom, we see some black plastic containers that I thought were really curious because we came across so many of them. And I actually wrote a blog post about this. So I got back some information, and someone had been tracking ocean plastics, and there are identifying marks on these kind of containers. And we found out that they were actually octopus traps that had broken free and migrated across the Atlantic Ocean from the African coasts, such as Mauritius, around that area. This is a group that got involved in the Clean Island sweep and picking up litter across the island. This is my husband and I after a long day of coastal cleanups, and our trusty assistant, at least one of them, taking some meticulous notes for data collection on the types of plastics that we collected. Now, a group of us also got together, and we were able to get the managing director for the Harvard Center for Health and the Global Environment to come down and teach the teachers. We thought that if teachers actually understood and got involved and immersed themselves in the natural environment, there would be greater appreciation of the coastal ecosystems that surrounded the island, such as the coral reefs and the mangroves, that kind of thing. So this is me. I got to take part in the week-long workshop and help the teachers get comfortable in the water, and eventually we took them out on a boat and went scuba diving in the deep waters. Right, so this is me taking part in this field classroom. Here I am trekking through a flooded section of limestone caves in Costa Rica, and then taking the family out for a weekend climate march during one of our trips back to Canada. So this final image that I'm going to show you is a view of the sunset from our front porch while we were living there. But why did I show you all of this? Mainly because during my time overseas and living in the global south, it became really apparent that there were those that did have the luxury to keep denying the climate sciences, and those who had to deal with the consequences of things like sea level rises, severe droughts, an increasing frequency and intensity of storms and mudslides, and these kind of things that impacted their life on a daily basis. It's important to understand that climate change, when we talk about it, it's not some far off construct that's going to affect some future generations 20 years from now. This is something that's having an impact on lives around the world today. So I'm going to start the science portion of our talk with one of these images from outer space. Now, this is the first image from the Apollo 17 mission, and it shows that our world is finite, our resources are finite. All of humanity, all of life on the planet is captured here in the image. our atmosphere in this other this other image from space, we see how thin our atmosphere is compared to the surface of the Earth. It's just a thin layer on our surface that supports life on our planet. So when solar radiation travels to our Earth, right, it hits and penetrates through that thin layer of atmosphere in the form of light waves. Now, as it passes through that atmosphere, it gets absorbed. It warms the Earth's surface. Now, some of that energy gets radiated back into space, right, in the form of infrared rays, right? So heat emanating off the surface of the Earth after it warms up. Now, there's natural things that actually reflect that heat energy back into space. And it's pretty much anything that you would see that normally looks white on satellite imagery. So things like clouds, the snowy tops of mountains, sea ice. But there's also things in the atmosphere, little particles that actually cause disturbance, cause reflectance. So things like the ash from forest fires that rises up into the air, the dust that spews out of a volcanic eruption, or even sand that blows in windstorms off the coast of Africa and over the Atlantic. So all of these have a slight cooling effect on the Earth's climate. So some of that radiation or infrared radiation gets reflected from those natural causes of reflectance, right? But a lot of it gets trapped by greenhouse gases. Now, we naturally have greenhouse gases. We need these as part of our atmosphere because the greenhouse gases are what keep the Earth's climate in that perfect Goldilocks temperature, not too hot, not too cold, right? So these are what we need to support life at those optimal temperatures. Now, as that atmosphere thickens, so with the industrial era, we started adding more man-made greenhouse gases into the atmosphere. So that atmospheric layer started to thicken. So it's absorbing a lot more heat, and that radiation gets trapped and causes surface temperatures to start rising. This slide here shows some of the different sources of man-made greenhouse gases, right? So things like air transportation and landfills, right? As stuff in the landfill start to decompose, right? We get some gas releases. They've got industrial processes, coal mining, and thermofrost releases methane from the ground. So we're spewing 152 million tons of these man-made these man-made greenhouse gases into the atmosphere every 24 hours. Now, by far the largest source of global warming or greenhouse gases is from the burning of fossil fuels. And we see it here. We see an increase exponentially following the Second World War, when we kind of turned to more patterns of consumption to kickstart the economy after the Great War. Now, all that heat energy being trapped in our atmosphere is equivalent to 600,000. That's correct. 600,000 atomic bombs going off every single day, right? That's insane, right? So if you've ever seen the footage of an A bomb or the bomb over Hiroshima, you see that mushroom cloud. Having 600,000 of those go off every day, that's the amount of heat that we're trapping due to man-made pollution. Now, this next video it's very cool visual. I really love it, right? And it shows that over time, from the start of the industrial era, how those temperatures are rising. And we see as time passes, there's increasing heat happening in the global north, so in the poles. right? So you'd see it getting hotter and hotter after World War II, early 80s. Now we're starting to see it really pick up speed. And that's because of that natural reflectance that we talked about earlier. So it's making a positive feedback loop. So as that sea ice starts to melt, it's being replaced by open water. So that dark, dark open water, and it acts like a t-shirt on a hot summer day. Now, if you're ever worn like a black t-shirt on a hot summer day, right, you're absorbing a lot more heat than if you were to wear like a white tank top or something like that. Now, with that, it's making a positive feedback loop because the more heat that gets absorbed by those dark surfaces, the faster the ice is going to melt. As the ice melts, it's being replaced by that dark surface, which is absorbing more heat, which is going to cause more ice to melt, and the cycle continues. So that's why it just picks up speed at the very end there. And you can see here, those temperatures are rising exponentially from the end of the Second World War. And nowadays, we're finding that we're breaking records for surface temperatures almost every year. And in 2020, when these slides were first put together, 2020 was on track to be the new hottest year on record. Since 2001, 19 of the 20 hottest years on record have occurred. Right? So we're seeing here 2016, the hottest year that we have, followed by 2019, 2017, 2015, 2018, right? They're the top 5 hottest years. So what happened with 2020? 2020 tied with 2016 for hottest year. But not only is the air heating up, but the heat content in the oceans is also increasing. So oceans kind of act as a heat sink. So they're absorbing a lot more energy than, say, like the land surfaces. Right? And half of that warming in the oceans has occurred in the last about 15 to 20 years. So I'm going to remind you of your science classes and the hydrological cycle, because as the Earth's temperatures start to heat up, there's more evaporation over the oceans. And that moist air is going over the lands, right? So more and more water is being taken up into the air. It's going over land, and it's causing increased precipitation, right? So that's more downpours, more snowstorms, sleet, hail, rain, you name it. Right? That's coming down in torrential storms. And we're seeing that water rush over the land and go back into the rivers and out to sea. So that's your hydrological cycle. And this is being disrupted by all these warming temperatures. So the Earth's climate is getting hotter and wetter and wilder. So this image here shows how ice is disappearing. This is a glacier in Greenland. And we're seeing a decline in ice that almost mimics the rise in heat temperature. Now, over the past 20 years, we're losing a lot of our ice mass. And while ice mass is going down, extreme weather and catastrophes are going up. They're on the rise. So things like storms, floods, mudslides, and extreme temperatures and droughts, because not only is that heat evaporating more water from the oceans, but it's also causing more evaporation from the lands. So that means drier soils, crop failures, longer droughts. And the hotter years are typically the same years that we get the most number of forest fires, right? So we're getting a large amount of fires in areas like California, or the big fires that we've had recently in Australia. This image is from Fort McMurray in Alberta. Right? So in 2016, there was a huge amount of fires. Wildfires were were happening, and over 100,000 people had to be evacuated from this area because of the wildfires threatening their homes. Fast forward 4 years, almost to the date, that same area has been flooded, right? And evacuations as well, because people's homes are now being flooded. And this is an image, I believe, of a community center in the Fort McMurray area. So we're seeing a lot of flooding. Sorry about that. We're seeing a lot of flooding in cities and coastal areas, low-lying elevations. What I have here is footage from Miami, Florida, where they're having flooding. So this flooding in the Miami Beach area was happening on a sunny day. There was no rain, no major storms, right? This is just from high tides, right? Flooding the streets. And we're seeing this in several coastal areas around the world. Coming back home to the GTA, this is flooding that happened in 2013 around the GTA. The sewer systems were backed up, so you see water coming out of our storm drains. This is an underground parking garage in Brampton where waters were flooding through the stairwells, right? So this is in July of 2013 that we saw these torrential downpours and flooding in the GTA. 2014, we saw the GO train lines being flooded in areas all over the GTA as well. My husband got stuck in this storm as well, trying to come home on the GO train along the lakeshore line. In this particular image you see in the corner, there's some canoeists that are coming to help evacuate passengers from the GO train, right? Because it was that bad. This is Burlington during that same period, right? The streets are getting flooded. So we see this car getting stuck in floodwaters, right? Roads had to be blocked off. We see floods happening all through the parklands and rivers rising. You see the trees are being totally flooded. And then the sports infrastructure and soccer fields are all of that is being ruined by the floods. So in the GTA, extreme weather events are on the rise. So we're talking about more heat days, cold alerts, ice storms, wind storms, you name it. But climate change is not just about extreme events, right? It's also a medical emergency. So in Canada, what we're seeing is that tropical diseases are on the move. So diseases that would never survived here because they're carried by insects. And those insects have a very finite geographical range that they can survive in. Now, because the climate's changing, those insects are able to migrate further and further south. So we're getting tropical diseases here in Ontario. So things like West Nile and Lyme disease are all migrating further and further north and becoming a threat to our populations. We're losing about 50% of our land-based species. Predicted that 50% of our land-based species are going to be extinct by the end of the century. So the cost of carbon is adding up. All of these are threats, right? Including many that we haven't even covered. And the World Economic Forum has said that climate change is the #1 threat to our global economy. Now, with threats come opportunities. We've done the research. We have the technology. We have the solutions. What we need is action to put those solutions into place. Globally, wind could supply all of our electricity needs. The global wind production could supply our electricity needs. It's at 40 times it's 40 times greater than what our global electricity needs are. We have enough solar energy reaching the Earth's surface every hour to supply the world's electricity needs for a year. So the question is, how do we drive change now? So countries across the world, in Paris, they signed an agreement to cut carbon emissions by the middle of the century. So by 2050, many countries pledged to go net zero. The US, since this slide was produced, the US has signed back on with their recent election. They've signed back on to the Paris Agreement. This image here is of Climate March in Montreal, Ontario, and this was the largest climate march that we've had ever. Over 500,000 people came out to show that climate change is something important to Canadians. Right? We care about climate change and we want something done. And as our youth, you guys have the power to make a difference. A recent study by the University of California, Davis, they looked at the carbon in our dietary choices and the power of our food choices. Everybody has to eat. And we're seeing that one serving of steak or red meat is almost the equivalent of driving 5 kilometers in your car. They were comparing different types of diets. So vegan by far is the lowest when we're looking at greenhouse gas emissions or equivalent emissions. Right? But Mediterranean diet is not far off. Mediterranean diet is mostly vegetables, right? Some soft cheeses and occasionally fish, maybe chicken once in a while, right? Now, if everyone were to adopt even a Mediterranean diet, it would be the equivalent of taking about 1 billion cars off the road forever. So food choices are within your power, and it has a tremendous effect. What I want you to do is join those who are using their voices, their votes, and their choices to fight the climate crisis. And I want to end with another image of our world, but not one produced by NASA. Instead, this imagery is courtesy of a student named Adam Cudworth. And he's a 19-year-old student from Ambersley in the UK. And what he did was strap the equivalent of a $50 camera to a helium balloon. And he had a GPS unit so that he could find the camera after it came back to Earth. But this equipment went up and he took these amazing photos, right? And it soared to a height of over 110,000 feet up into the atmosphere to take this imagery. Right? It took 2.5 hours to get up there. And these are views of Earth from space. Thank you so much for taking part in my Climate 101 presentation. And I hope you enjoy the rest of your virtual conference. Thank you very much. Bye.
Thank you so much for listening to Marsha Smith talking about Climate 101. If you want to take climate action, don't forget to register for the project launch to reduce greenhouse gas emissions. You can find the registration link on the main page.